This is page 28 of your notes, and today we talk about vectors. Vectors are simply directed line segments, so I'll highlight that. Directed line segments representing a quantity that has both magnitude to it. So magnitude, and magnitude we want to think about as length or distance. So above that I'm going to also write distance. And something called direction. Okay, so when I think of something in the real world, like for example, last night I was trying to capture a screenshot, but I was watching the news and the wind segment came on, and they had a map with a bunch of cities on there and arrow segments pointing in various directions. And so the arrow with wind, the arrow represents the direction in which the wind is pointing. So for example, northeast, or not pointing, but blowing. And the magnitude would be the speed of it. So 45 kilometers per hour. And then let's say in a northeast manner. So the direction is the northeast part. The magnitude is the speed part. So in symbols, vectors are represented as two coordinate points, very similar to how we see array representation, except for with the vector notation, you would have the initial point or the end point being right above A, and then instead of drawing the full arrow tip, and let me zoom in on how I'm drawing this, you would see just the upper portion of that arrow. So this is vector AB, and let me draw for you vector AB. So this is the first point that I'm drawing is what we call the initial point. So this is A and pointing in a specific direction, and then the end of that ray is going to be what we call the terminal point. So where A is the initial point and B is the terminal point. So just to make a point of this, vector AB can be pointing in a different direction and named the exact same way, so long as your initial point is still A and your endpoint is still B. So this is also described as vector AB. So you see the initial point is A and the terminal point is B. Now I would describe this vector and this vector the same way, and sometimes there's a secondary way of describing it. So if you open a physics book or a calc book, you'll see also vector notation written as a single letter, similar to when we described a line just using a cursive L. Vectors are also described using a single letter. So for example, this I can describe as vector V with the same half arrow on top. So I will fill that in at the very end of that sentence. So a single letter with that notation above that. And so there's two big things that we usually have to find or we're given to draw the vector, and that's magnitude and direction. Okay, so the magnitude is denoted by these absolute value symbols, and oftentimes you'll even see a double absolute value sign for magnitude, and that represents the length of the vector. So we're going to think of length as distance eventually, and the direction is going to be the angle measure that's formed with the horizontal. So when I'm looking at, let's call this example number 1, I'm going to draw a vector in the first quadrant on a coordinate plane with the initial point on the origin and the terminal point somewhere in the first quadrant. And actually, just to be consistent here, actually we'll say that this is about half of 90 degrees. So we'll say this is a 45-degree direction, a vector AB pointing in a 45-degree direction. And I would describe this as the direction of vector AB is 45 degrees relative to the horizontal. And the way that I have this vector positioned nicely with the initial point on the origin, we would describe this as a vector that is in standard position. And what makes a vector in standard position nice is that the initial point is on the origin, and it helps us to find things like magnitude very easily. It helps us to find direction fairly easily, as opposed to, and you don't have to draw this out, but on the right hand side we could have a vector over on the second quadrant and maybe on the fourth quadrant but it's nice for us to be able to move these vectors such that the initial point is on the origin so that we can make a simple comparison between the two to see if they're pointing in the same direction and to see if the magnitude or the length of those vectors are the same. So oftentimes what we'll do is we'll move the vectors that are currently not in standard position back to the origin with the initial point on the origin so that it's easy for us to compare. And that process is putting it into something called component form. Okay, so component form simply takes the coordinate points of the terminal point and puts it inside these funny looking brackets. So these funny looking brackets look like parentheses, but they're sharp, or you can think of it as less than symbols and greater than symbols. So a vector in component form is represented basically, we can take each one of these, and the process of moving it back into standard position is putting it into component form. And it's actually relatively easy to do. We just have to figure out what the change of x is and the change of y. So it's going to sound very familiar to you guys doing things like slope, or when you guys were calculating and trying to figure out what the rise and run was of slope is very similar. So in component form, the way that we put it into component form is we find the change of x and we find the change of y. So recalling back what that meant in Algebra 1, that meant take the x coordinate, subtract the 2, take the y coordinate, subtract the 2. And so if I use this figure 1 as an example, the component form of this vector would be my change of x. So this is, let's say, x1, y1. And this is x2, y2. So vector component form of vector AB that we see in figure 1 would be 5 minus 0, comma 3 minus 0. And that would simplify to be 5, 3 in component form. Okay, so to find the magnitude of something, so if I asked you to find the length of this vector, I hope you would think, okay, well, we could form a right triangle here. If I drop down the altitude and I form it with the horizontal, I see that the change in x here is represented as one of the legs. This is 3, whereas the change in, I'm sorry, if I said change in x, I meant change in y there. The change in x is 5. So to find the magnitude of vector AB, we would say the magnitude, again, the double absolute value bar symbol is magnitude, is equal to distance formula or Pythagorean theorem. So I will first write for you the formula for distance formula just so you have it in your notes, but change in x squared minus or plus change in y squared. So here in this case, we can also view it as doing the change of x we've already done. That's 5. The change in y is 3. So it's the square root of 5 squared plus 3 squared. So in this example, we want to then simplify that down to be the square root of, and I'll write it here. This is where actually the example was supposed to be completed. Vector AB is 5 minus 5 squared, which is 25, 3 squared, which is 9, or in other words, radical 34.